Hey everyone, Katrina here, and today I'm going to show you how to solve trigonometric equations using substitution. Be sure to subscribe for more videos like these. Let's dive in. Okay, so in my previous videos, I talked a lot about solving trig equations. Plainly using ratios, using the cast rule. Be sure to check that out if you need some background. But today we're going to use substitution in order to solve more complicated looking trig equations where there's more than just one trig term that we're dealing with. We have a whole equation. So let me show you like a situation, for example. What if we have 3 cos squared x plus cos x equals to 2. And in this problem, we want to solve for x, and then x is an element between 0 and 2 pi. So we always have to make sure that we're stating our domain because trigonometric functions are periodic, so they will keep repeating for an infinite amount of times. So to avoid writing an infinite amount of solutions, it's good to define our domain in which we want to find our answer. Okay, so looking at this right off the bat, this looks a little bit confusing. How can we solve for x if we have 2 cosines, we have 1 cosine squared? Okay, where do we start over here? Well, this is where we have to use our knowledge and understanding of polynomials and quadratic functions. Does this give you a little bit of a hint of maybe a quadratic function? I see a squared sign here. This one's to the power of 1, and then I have some constant value here. This is looking a little bit like a quadratic function to me. So why don't we go ahead and do a substitution? So let's just say let a equals to cos x. This way we don't even have to worry about trig functions. We're just going to solve this plainly as a polynomial, a trinomial in this case. So what do we get here? We now have 3a squared plus a equals to 2. Let's rearrange this to have 0 on the right hand side, because whenever you solve an equation, you should always set it to 0. So now we have 3a squared plus a minus 2 equals to 0. And hey, this looks very quadratic in nature. This is where I will refer you to my quadratic factoring videos. I have many crash courses that go over all the methods how to factor quadratics, so be sure to check that out if you need some factoring refreshers. So let's go ahead and then solve this quadratic equation. So this one, we can use the product sum rule in order to solve this. So in this case, our product is going to be -2 multiplied by 3. Where did I get those numbers from? I took my constant multiplied by my leading coefficient. Okay, so 3 times -2 gives me, whoops, wrong color. That gives me over there, sorry about that. Okay, that gives me -6. Okay, and now I want to find my sum. How do I get my sum? I'm just going to take the coefficient of my middle number. So if you have no explicit coefficient, it means it's 1. So my sum equals to, in this case, 1. So now I need to find 2 numbers that multiply to -6 and add to 1. Well, 3 and -2 work, because 3 times -2 gives me 6, and 3 minus 2 gives me 1. So now what I have to do is, since I have a leading coefficient other than 1, I now divide, or I guess decompose, my middle number into these two. So I've got 3a and -2a. Okay, so let's go write that out. So I've got 3a squared plus 3a, and then I have minus 2a minus 2, oops, equals to 0. And I'm going to now go put some brackets on here so I can work on factoring this. And then we still have a plus sign there in the middle. Okay, so let's go ahead and factor out from both of these terms. So here I can factor out a 3a, which gives me a plus 1. And then here I can factor out a -2, which gives me a plus 1. And then I set that equal to 0. So what can I do next? Well, now that was able to factor and end up with a term that was the same, that means I factored correctly, and now I can actually take this a plus 1 and factor it out of the whole equation. So I've got a plus 1, and then look what's left. I've got 3a minus 2, and this equals to 0. Okay, so to solve any equation, what do we have to do? We have to set both of our sides equals to 0, and then solve for a. So from this side, I have that a equals to negative 1, and here I have that a equals to 2 over 3. Okay, are we done yet? Not quite, because what was our initial question? Our initial question was in terms of cos and x, not in terms of a. So we now have to go and substitute back in. So we said earlier that let a equals to cos x. So we need to put this substitution back in. So that means that we're now going to have cos x equals to negative 1, and we're also going to have that cos x equals to 2 over 3. Let's go ahead and solve these two separately. So in my previous videos, we looked how to solve things using putting them on a unit circle and understanding the different quadrants and what that means. So let's go ahead over here. So also looking at our ratio, we know that cos is x over r, which can be seen as adjacent over hypotenuse. So we can write that out, where r is our radius. Okay, so let's see what that means for us. So we'll draw out our unit circle, and we know our domains between 0 and 2 pi. So let's fill in all our reference angles, 2 and 2 pi, and let's write out our cast rule, which tells us which quadrants are going to be positive or negative for each trig ratio. So here we have that cos is equals to negative 1. So that means it can only be negative in the second and third quadrant. So where this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So cos is negative in 2 or in 3 because only sine and tan are positive in those two respective quadrants. Okay, so here we see that we have x over r. R is the radius, which can never be negative. So you can kind of write this as negative 1 over 1 because any number divided by 1 is the same as what it is. So what does this mean for a ratio? Well, it means that x is negative 1 and r is also equal to negative 1. So that means that it's actually going to lie literally on this axis over here. Interesting. So it's negative 1 in the x direction, and then the radius has a magnitude of 1. When we have stuff that lies on the actual axis, it's a lot easier to actually look at the graph itself instead of trying to work with the unit circle. It's one of our exception cases. So let's draw out cos between 0 and 2 pi. We know that cos has a maximum at 1 and minimum at negative 1. When does it achieve the minimum of negative 1? Because that is our value in question, right over here. Well, this occurs at an angle of pi, which is exactly what we can see here because the line lies on pi, and we can see that it reaches this value of negative 1 when it is equal to pi. So then that is one of our answers for x over there. We have that x equals, we'll just say x1 equals 2 pi. There we go. We've solved already for one of its values, and this also falls within our domain. This was how we can find it without using a calculator. You can always have the option of plugging it in, but I don't always recommend using a calculator because sometimes it will just obviously give you an answer in decimals and they would approximate your answer. So it's always better to look for your exact answer when possible. But if you wanted to use a calculator, you could use cos inverse. So you would write it as x equals to cos inverse of negative 1. And also note that I'm giving your answer here. This is in radians, not in degrees. Okay? So now let's look at our other side. So we have cos x equals to 2 over 3. Let's draw that out. So x is so we have 2, we got our cast rule. So where are we looking? Cos is positive, so that means it's in the all quadrant or it's in the cos quadrant. So this is quadrant 1 or quadrant 4. So that following our bow tie rule, which I mentioned before, our answer is going to exist in quadrant 1 or in quadrant 4. We have that our x value here equals to 2, which makes sense because it's on the positive axis, and then our radius equals to 3. Okay, first thing you always want to check is, do I have a special triangle? Because if you have a special triangle, then you could easily find what is your degree, or what is your angle, your internal angle there. But I hate to break it to you, 2, 3, this is not a special triangle, so unfortunately we'll have to resort to using our calculator. So that means that x is going to equal to cos inverse of 2 over 3. Okay, if we plug in this into our calculator, what do we get? We get approximately 0.84 radians. Remember, this is radians. You don't have to write rad next to it. I'm just doing this so you know not to confuse it with degrees. Okay, but we, through our analysis, determined that we should have 2 angles for this on our domain from 0 to 2 pi. But what our calculator did by default is it gave us this angle over here. So it gave us here that alpha equals to 0.84 radians. But we know that we have to use our analysis here to find our second angle. So let's write out all our reference angles. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So in my previous video, I showed a pretty cool trick. How do you find your theta given your internal angle alpha? So we said that if it's in quadrant 1, then theta equals to your alpha 1. So we know that our first angle for x, we have our answer already at 0.84, but what about our second angle? So we need to start here on our principal axis and go all the way around, and this is going to be our theta 2, which is our second x value. So to find this one, it's going to exist in quadrant 4, so we use our reference of 2 pi minus our internal angle alpha to get our theta 2, our second angle. So in this case, we will have 2 pi minus 0.84, and let's see what that gives us. So we have 2 times pi minus ants, and that gives us about 5.44 approximately. Okay, so this is our second. So this here equals to 5.44 radians. So let's collect all our solutions. So we found that x1 equals to, what do we say over here, pi, from our first one. x2 equals to, let's grab this answer over here, 0.84 radians. And then x3 is going to equal this final answer we found of 5.44. So I just use our x and theta interchangeably here because it just shows that theta represents our angle. So this problem was a little bit more involved. We had to first use substitution, then we had to use factoring methods for quadratic factoring. We then went on to substitute our trig back into our function, and then we had to use our knowledge of unit circles and the nature of the trigonometric functions in order to solve for our answer. It's a really great example to really test out all your trig skills. If you need help in one area in particular, be sure to reference some of my other videos, which are very skill specific. And again, if you have any questions, please don't hesitate to reach out in the comments, and definitely subscribe for more videos so you can stay up to date. And with all that, I'll see you next time.